Right, we have an aircraft being refueled here. There's the refueling truck and it's connected by the refueling hose there. The aircraft is connected to an earth wire before pumping fuel. Give one reason why earthing reduces the risk of fire. Okay, so before they connect this hose, they connect a wire to the aircraft to earth it. Right, so why do they do that? Here is the textbook answer, okay? It's only a 1 mark question. Firstly, say earthing discharges the aircraft, okay? Earthing discharges the aircraft. Right? Say the obvious if you like, exam technique. Now, if the aircraft were charged, it could discharge suddenly when the fuel hose is connected, which can involve a spark, which can ignite the fuel. Okay, that's more than enough for 1 mark. So I'm saying, write that out, what I said in a full sentence, but shorthand, a discharge can, it may discharge when the fuel hose is connected, and that's bad because a spark can ignite the fuel. Okay, you want the discharge to happen when the earth wire is connected. You definitely don't want it to discharge through the hose, the fuel hose. Okay. Explain how an aircraft can become electrically charged as it flies through the air. 2 marks. Right. Textbook answer again. Let's go through it. So, first thing, as an aircraft flies through the air, it collides with the air at high speed. Okay, so aircraft collides with the air at high speed. Okay? This generates a lot of friction between the aircraft and the air. Okay? Friction is the key to this. Friction leads to electron transfer between the aircraft and the air, and therefore a charge can build up on the aircraft. That was 2 marks, and that is a textbook answer for the exam. Say things in a logical order. Lay them out nicely like that and you'll get the marks. Okay, right, some sums. We are told that the weight of fuel going into the aircraft, so the weight is 230,000 newtons. The fuel moves up a vertical height of, so the height is 4.7 meters. The power developed by the fuel pump inside the truck is 1,600 watts, and we have to calculate the time to refuel. Okay? Right. So, they've given us power. Power, I'm going to write as P, height H, weight. Weight is a force. I'm going to write that as F. Okay? So, power is the energy per unit time. It's the rate at which energy is, I hesitate to use the word used because energy isn't really used, it's always transferred, but it's the energy that the pump is transferring per unit time. So power is energy over time. That's the equation that we need. That's what I'm getting at. Okay? Right. So we're after time. We want that. We've been given the power. Good. So if we get the energy, then we've won. So what's the energy? Well, we're raising up a bunch of fuel by a height of 4.7 meters. So that's gravitational potential energy, isn't it? So the GPE, I wouldn't blame you for immediately reaching for the equation mgh. When you lift something up, like when I lift this pen like that, I'm giving it gravitational potential energy. Whenever you lift a mass up through a height, we're talking about GPE. And you're told, and it's true, that the energy you give to the thing that you lift up is its mass times gravitational field strength times the height you lift it. Is that useful in this case? We don't know the mass of the fuel. We've got its weight. G, well, we know G, it's either 10 or 9.8 or 9.81, but we do know the height. So we haven't been given the mass. We know the weight instead. So this isn't immediately useful. Now, yes, we could say that we could use the equation F is mg, okay, that the force exerted by the fuel downwards is equal to its mass times gravitational field strength. So, in fact, that's what we kind of are doing. The force exerted by the fuel downwards, that's what we've been given, its weight, 230,000 newtons, is equal to its mass times gravitational field strength. So we're going to sub in F into this equation. So therefore, GPE is force times height. So the weight of the fuel multiplied by the height we lift it is equal to the energy it's been given. Good. Now that equation, that's what we're going to use, but that's also the same as the equation that energy is force times distance, okay? You can also, I'll just put it in brackets, energy is force times distance. That should also be a familiar equation to you. So that's how the equations for gravitational potential energy and energy is force times distance are connected through that. They're essentially the same equation. So that's what we're going to use. Energy is GPE, or energy, that is the energy. Gravitational potential energy is the energy, same thing, is force times height. So using that and putting it into here, we get that therefore power is energy is force times height divided by time. And we want the time, so therefore we just have to rearrange this equation. Bring time up here, the P down there. Time is force times height over the power. Therefore, time is, stick the numbers in, force is 230,000 times the height is 4.7, all divided by the power, 1,600. It's in the correct units, watts. 1 watt is 1 joule per second, that's what we want. That's in meters. Yeah, that's in newtons. All good. Stick it in your calculator and you get 675.625. We're not going to leave it like that. We need a nice sensible choice. Let's go with 676 seconds. And that's to 3 significant figures. There you go. That's how it's done. Right, this next bit. Let's have a change of colour. We have a car door. Right, what do car doors look like? Something like that. Close enough. And a spray gun. What do spray guns look like? That'll do. Right. This spray gun is firing paint at this door. Now, the paint is positively charged. Okay? The door is negatively charged. Right? Good. Now, question. Explain how charging the door helps the paint form an even coating on both sides of the door. Okay. 2 marks. And it tells you you should use ideas of forces and fields. So when they say something like that in the question, do what they tell you, okay? So we've got to talk about fields. Right. It's only 2 marks. We should be able to get this one. Firstly, say the obvious, okay? Exam technique, say the obvious, and there's a good chance you'll get a mark. First thing to say is that the negative door attracts the positive paint droplets. Okay? Probably got a mark already. Right, now the question, it was asking how does it help form an even coat on both sides of the door? And it wants us to talk about forces and fields. Right, so it asked about both sides of the door. So let's redraw this, looking at the door side on. Okay, side on view. Now, the field lines are the key to this question. That's what they're getting at, really, okay? The electric field lines on this door look like this. They're all pointing towards the door, okay? Because the door is negative, the paint droplets are positive, so these electric field lines, these lines of force, they're pointing towards the door because they're attracting the paint droplets towards the door, okay? So it's going to look something like this. Okay? Now, I would recommend a quick little diagram just like this if you get asked this sort of question in the exam. Diagrams are often a good idea, okay? They help explain what's going on, show the examiner you know what you're talking about. Okay, so we've drawn the door side on and we've drawn the electric field lines. Label the diagram. Okay? And then explain it. So, say that the electric feel lines point towards the door on both sides of the door. Okay, therefore the paint is attracted to the door on both sides. Okay, and that will get you your 2 marks. So I know it's only a 2-mark question, but I think it's quite easy to not get the 2 marks here, and I don't want you to make that mistake. And you would not get the 2 marks if you didn't listen to what they were telling you in the question. They told you to use ideas of forces and fields, so that's what we did. Okay? And the question, make sure you know exactly what they're asking you. The question said, how does charging the door help the paint form an even coating on both sides of the door? So they're leading you in this direction of electric field on both sides of the door. Okay? So that's just a lesson on reading the question, using exam technique. Nothing wrong with a little diagram. And if they tell you to talk about fields, talk about fields. Good. And that's it. There we go. Fantastic.